All right, good morning, everybody. Today we're going to be learning how to model with expressions. So our central question today is, how do you interpret algebraic expressions in terms of their context? So the first word that we're going to look at today is expression. And an expression is just a mathematical sentence. So remember how an equation was a mathematical sentence with an answer? An expression is just the sentence. So there's no answer to this. So a mathematical sentence. And an example of an expression would just be like 2x plus 3. That is a mathematical sentence. That is an expression. There is no equal sign. Terms are the parts of an expression. So the terms in the example that we had of 2x plus 3, well, 2x would be a term and 3 would be a term. They're just the numbers, the parts of the expression. That includes the variables. And a coefficient, you should be familiar with a coefficient, but a coefficient is the number in front of a variable. And again, looking at our example of 2x plus 3, the coefficient there would just be 2, because that is the number in front of x, and x is the variable. So that's our vocab for today. So let's start in an example. So in this example, we're going to interpret the expression in the context. And here you're really going to want to use your reading skills. So like highlighting, underlining, all of that good stuff. So Enrique is buying school supplies. He buys P packages of crayons and at $1.49 each, and Q packages of markers. We want to know, what does 1.49 P plus 3.49 Q represent? So let's start with highlighting the important information. So I'm going to highlight in green the P, because P is a variable and it stands for crayons. And I know that they are $1.49 each. I'm also told that there are Q markers, packages of markers. So Q represents the markers. And I don't know how much they cost. But I do know that I'm trying to understand what 1.49 P plus 3.49 Q represents. Okay, so the red represents what I'm trying to think. So we need to just stop and think, well, what do we think the 1.49 P represents? Well, if I look up here, remember P stands for crayons, and I know they cost $1.49 each. So 1.49 P is going to represent the cost of crayons. So I'm just going to write that down. So 1.49 P is the cost of crayons. Again, I'm just taking that from what I just read. P packages of crayons and $1.49 each. So 1.49 P has to represent the cost of crayons. So then let's ask, well, what does 3.49 Q represent? Well, 1.49 P represented the cost of crayons. So 3.49 Q must represent the packages, the cost of markers, because Q represents markers, and 3.49, that's a cost. So let's write that there. So the cost of markers. Now breaking this up, 1.49 P plus 3.49 Q, well, I'm adding those two numbers, and usually when I add those two things, I get a total. So I'm going to say that 1.49 P, the cost of markers, crayons, plus the cost of markers, which is the total cost. So I'm just going to write that. I'll put that in red. So it's the cost of crayons plus the cost of markers. I'm using words for this expression. And that's all we got to do. It's the cost of crayons plus the cost of markers. So it was pretty easy. So let's go ahead and look. I'm going to go and box that so you know that's our answer. So here, all we're just trying to do is interpret what the expression means. So in part B, Allison is buying an inkjet paper and LaserJet paper for her business. She buys 8 more packages of inkjet paper than P packages of LaserJet paper. Inkjet paper costs $6.95 per package. We want to know, what does 8P plus $6.95 plus 8 represent? So same strategy. We're going to highlight the important information and then try to interpret what each part means. So she buys LaserJet paper for her business and inkjet paper. We know she buys 8 more packages of inkjet paper than P packages of LaserJet. And I'm just highlighting P in yellow because that's paper jet. That's a different type of paper. So she buys 8 more packages of inkjet paper than she does of the paper jet. The LaserJet paper is $6.95 per package. And we want to know what our expression represents. So 8P plus $6.95 plus times P plus 8. So it's starting out with the 8P. So what does the 8P represent? So P stands for LaserJet paper. And so I'm going to say 8P represents 8 packages of LaserJet paper because there's a P and there's an 8. Usually when we have a number in front of a variable, actually always when we have a number in front of a variable, it's like the amount of that thing. So 8P would be 8 packages of LaserJet paper. Okay. And so 695 of P plus 8, well, 695, remember, represented the cost of inkjet. In parentheses means times, so multiplied by, yeah, it's bleeding into the next part. So I'm going to go ahead and actually put it over here. So it's the cost of inkjet paper multiplied by 8 more than the amount of ink. Okay, and actually, I think 8 packages. I think that's going to be the cost, not the packages, but the cost. Sorry, going backwards. It's the cost of LaserJet paper, which is just weird because they didn't tell us the cost of the LaserJet paper. Okay. But just thinking about it, it's not going to make sense for that to be the amount because the variable is representing the amount. So the cost of the inkjet paper multiplied by 8 more than the amount of inkjet paper, which is, remember, so basically, if this is the cost of the LaserJet paper, is it LaserJet? Sorry. Then this has to be the cost of the inkjet paper. I'm sorry, this is supposed to be LaserJet. Sorry, guys. I'm not quite awake yet. So bear with me. All right, so this has to be the cost of a LaserJet paper. Sorry, inkjet. Remember this good? This comes from the fact that we are told up here that for the inkjet paper, she's buying 8 more packages of inkjet paper than she is of the LaserJet paper. So this has to represent the cost of the inkjet paper. So again, when we put them together, this is the cost of LaserJet paper added plus, well, we'll just start plus the cost of inkjet paper. And so some of you, it might look confusing because it's 695p plus 68 times plus 8, p plus 8. So, but you have to remember equivalent expressions are expressions that are equal. So 3x plus 6 is actually the same thing as 3x plus 2. Because if we multiply the 3 into the x and the 2, you get 3x, and then 3 times 2 is 6. So that's called the distributive property. And so that would be, if I multiplied the 695 in, it would be 695p plus 695 times 8. And some of you, when you're doing math, you're actually doing this in your brain. You just do it, and you're doing that same thing. You're doing the distributive property, and then you put it together. So what we're doing in this section is we're just working on formally writing it out in math so everybody else can understand it. So in this next example, it's kind of a little funky, but we got to think about it. So we're given X and Y, which are the populations of two different cities, where X, we know so X is bigger than Y. That's what that alligator means. Remember, the alligator eats the bigger number. So X is bigger than Y. And I'm going to go ahead and highlight that because it's actually important. And sometimes we miss important information. It's not all of it. No. Yeah, we'll just leave it there. So X is bigger than Y. We want to compare the expressions and tell which is greater. So if X is bigger than Y, that means X could be like 1,000 and Y could be 100. So X is bigger than Y, then which of these is going to be bigger? X plus Y or 2 times X? Well, remember, X is bigger than Y. So 2 of the X's is going to be bigger than X plus the Y. Because again, if we think about a number, if X is 1,000 and Y is 100, then 1,000 plus 100 is 1,100. But 2x would be 2 times 1,000, which is 2,000. So 2x would be bigger, right? Because 2x is bigger than 1,100. Again, just a hypothetical number, but you could plug any number in and it's going to say that 2x is bigger than x plus y in all cases. And so we're going to use our equation tool. So 2x is going to be bigger than x plus y. And again, this is because x is bigger than y. So 2x's is bigger than the sum of x and y. I'm actually going to make that smaller. All right, so then the next one, we want to know if x divided by y and y divided by x. Again, if we plugged in numbers here, like let's say x is 4. Let's say x is 4. And then y is 8. Okay, y has to be less than y is equal to 2. Then which has to be bigger? Are we going to have 4 over 2 bigger or 2 over 4? Oops. All right. Or 2 over 4. So that's really, when you're looking at these type of questions, it's kind of helpful to put numbers into it to make sense of it. And if I look, well, 4 divided by 2 is 2. 2 divided by 4 is 1/2. So actually 4 over 2 is going to be bigger. So that means that x over y is going to be bigger. And again, I just got the 4 and the 2 out of my head. Just a random number that I could check. I knew 4 was bigger than 2. And so that would satisfy x being bigger than y. We're just going to say x over y is going to be bigger than y over x. And this because like formally, this is why, because of x and y. So because x is bigger than y, then x divided by y is always going to be bigger than 1. X divided by y is always going to be bigger than 1. But y divided by x is always going to be smaller than 1. So kind of cool. And again, like it seems difficult, but it's not that bad. It's just like you need to stop and think a little bit. I'm gonna go box those answers so that way they're like separated. I'm gonna go and box our answer from up here too. All right, so just some different words that we can throw in that mean different things. So for example, adding, we have the word sum. Sum is for add. We also have plus, more than, add. Those are also words that mean to add. Some words that mean to subtract would be minus, subtract, difference, and less than. And obviously there are more, but those are just some that you will see. To multiply, you would have multiply. You would also have times. The other one is product. Product means to multiply. So those are some words that represent multiplication. And then finally, division. Division has some words specific to it. So words that mean to, let's keep that right. Words that mean to divide would be quotient. Yeah, quotient. And so those are some words that you might see. And so if you see some, then you know that the operation that you need to do. So remember here where we're writing expressions, the operation you would need to do would be plus. All right, so in this, we're actually going to write an expression in simplest form to model the given context. So in the real world, we're going to use expressions to code real life. It makes it easier. Like we don't always want to be solving problems by writing a bunch of words. Personally, I find it a lot easier just to write down a mathematical sentence or an expression because I can solve that. And that's what we're going to do here. So we know, so for this first problem, we're looking at the price of a Snickers bar plus 6% sales tax. So we don't have sales tax here in Oregon, but in every other state, there's a sales tax. And the sales tax is a percentage that you're paying of the product that you're buying in addition to the product. So for example, if I buy a candy bar, that's $1, then the tax on the candy bar would be 6 cents with a 6% sale tax because it's 6% of $1. So for total, when I would go to pay for the candy bar, I would pay $1.06. So how we're going to write that in our expression is we'll highlight the important information. So the price of the Snickers bar is important. Plus is my operation. So I'm going to highlight that in red because my operation is like one of the most important thing. Plus the 6% sales tax. And again, what I know about sales tax is a percentage of the product I'm buying. So let's have S represent Snickers bar. So I'm going to have this Snickers bar plus the 6% sale tax. So 6% of the Snicker bars, and 6% as a decimal is 0.06, and Snickers. And so you could leave it like that. I'm not sure if my HMH wants to simplify it, but if you simplify it, then you just add this. Remember, this is technically 1s, right? So 1s plus 0.006s is the same thing as just 1.06. Those are the same thing. Both answers would be acceptable. Okay, and again, Snickers bar plus 6% sales tax. That's exactly what this says right here. The next, we're looking at the price of a Lamborghini plus an 8.5% sales tax. So really, we're kind of doing the exact same thing. So I want you guys to see if you can do this by yourself. Pause the video if you want to, and then I will take a look at it. So price of a Lamborghini plus 8.5% sales tax. All right, so hopefully you've had a chance to try it. I'm going to go ahead and put it down. So Lamborghini, I'm going to use L to represent Lamborghini. So it's Lamborghini plus 8.5% sales tax. And so same strategy as last time. 8.5% is 0.085 of what I'm buying, which is Lamborghini. And that's going to simplify to 1.085 L. Again, the 1 just comes from the 1 L that I have here. And that is our answer. So our question today, again, was how do you interpret an algebraic expression in terms of the context? So hopefully now you guys have a better idea of how to do that, and you're ready to try some problems.